Morning students. In this lecture we will be studying about polynomials. Chapter 2 of class 10, polynomials. So let us first understand the basics of polynomial. What is a polynomial? So for a polynomial. So a polynomial ax power n, a1 an xn, a n minus 1 x n minus 1 plus a n minus 2 x n minus 2 plus this a 0. This is expression is called a polynomial p of variable x. This polynomial px, this is denoted by px equals a this. Now this polynomial is having a degree. What is called as degree of n. Why n? Because the maximum power of x is 1. Now when this will be degree n? When a of n, this value of a of n is not equal to 0. So if this is 0, then maximum degree will lie is a per n. If this is also 0, this is also 0, then a n minus 2. Now it doesn't mean that for every polynomial there will be x only. This can also be p of v. So suppose it's 5v5 plus 2v square plus 3v plus 1. So here this is polynomial of variable v, and degree is maximum v is 5. Degree is of this polynomial is 5. If this p of v I write is dash 0 v power, I can also write as this 5v power 5 plus 2v power 2 plus 3v plus 1. See, here degree is 6. No, here degree not 6. Here maximum value of n is 6, but a is not. A equal to 0. A of 6 is 0. For v of 6, a of 6 is 0, which implies degree is not 6. Degree is only 5. That's why I have written that for a n not equal to 0, the degree of this polynomial is n. Degree of this polynomial is n. So next, some basics. I'm giving you some basics. Now you must be knowing that dividend equals divisor multiplied quotient plus remainder. These two are same. This remainder. In polynomial also this is true. Polynomial also this is true. Suppose I'm saying that, see, for let us say that this is 8 and 2 is a factor of 8. Factor of 8, which implies that 2 into 4, 8 can be expressed in the form of 2 into 4. This is this. Or 8 can also be written as, I'm saying, so this time I'm thinking 3 to 6 plus 2. This plus 2. Now if you look at this figure, this is 8, this is 3, and the 6 plus 2. This plus 2. So this number cannot be greater than this number. 2 cannot be greater than 3. Is the first thing. This is the remainder, the degree of remainder. So in polynomial case, degree of remainder should not be greater than degree of divisor. It will always be less. 2 is always less, either it is 1 plus 2 it is 0 also, but it cannot be 3 or more than 3. So dividend equal to divisor into quotient plus remainder. Now in case of polynomial, well, I want to divide x square plus 2. I'm dividing, this is my one polynomial e1x, my another polynomial is x to the power 5 3x4 plus x cube plus 2x square plus 1. I want to, this is my p2 x. Now you can see that degree of p2x, degree of polynomial p2x, it is 5, maximum is 5, is greater than degree of p1x, which is 2, degree of p1x, which is 2. Consider this is 2, this is 5. So I can write p2 in terms of p1. I can write p2 in terms of p1 into some polynomial fx plus gx. Now, how can I write this? I want to divide this x square plus 2 it's x5 3x4 x square. x5 plus 3x4 plus x cube plus 2x square plus 1. Now how to write this? So degree of this is 2, this is 5, this is greater. So how much you have to multiply x square by 2 to get 5? This is x cube. If you multiply x square by x cube, this x will be added by 2 plus 3, think about x power 5. So multiply this by x power 3, so x power 5 plus 2x power 2. Now to subtract this, minus, so this will get cancelled, and this you can get 3x4 minus 2x cube plus x cube plus 2x square plus 1. And in it is x cube. Now this expression will turns to be nothing but 3x square minus x cube plus 2x square plus 1. So how much you will multiply? So this is 4. X square, if you multiply x square by x square, it will give x to the power 4, and if you further multiply by 3, it will give 3 power x power 4. It implies that plus 3x square, because 3x square into x square equals 3x4. And you only need to see this thing, first number. Now, so if you multiply by this, you get 3x4 plus 6x square. To subtract this will get cancelled, and here it will be minus x cube minus 6x square plus 2x square plus 1. Further, you can write it as minus x cube minus x plus 2 minus 4x square plus 1. For x cube and minus, so you can minus into that. It's like that. X square into minus of x is minus x. That's why for this I'm subtracting minus of x cube, minus of x 2 of minus x. 2. If you subtract this will get cancelled, this will become plus, and this will be plus, cancel, and minus of 4x square plus 2 plus 1. If you solve again, this will be minus 4x. This will be minus 4x square plus 3, and to get minus 4x square from x square you need to from minus minus 4, right? Minus 4. It will give you minus 4x square, and minus 4 is minus 8. So it will become this. So times 1 minus become this. So if you this will get cancelled. Subtracting this 2, this will be 11. So entire polynomial p2x can be written in form of p1x to fx plus gx. So p2x written as x square plus 2, right, plus 2 into x cube plus 3x square minus x cube plus 3x square minus x minus 4 plus 11 plus 11. So this is p2x, this is p1x, this is fx, this is gx. I'm just giving a simple denomination to this. Otherwise, this is some dividend equal divisor multiplied by quotient plus remainder. This is so we will see that from here the degree of gx is less than the degree of p1x, and it should be. Now very well know that I'm noting normal polynomial by px and px. What is p of x equal to 0? Equation gives. If I write px equals 0, what does this symbolize? Yes, let us suppose that px is 3x plus 2. If you take px equal to y and you draw the graph of this, this is x-axis, this is y-axis. Draw this x and equal to 0. For this x equal for y, for px of x equal to 0. If you draw this graph, then x equal to suppose this is it, and y I am taking y equal to 3x plus 2. If I have 3x plus 2, then you can consider y equal to 3x plus 2. It implies that if x equal to 0, y is 5. X equal to 0, y is 1, 2, 3, 4. So it will be here. Point will be here. If y equal to 0, x is minus 2 by 3. Minus 2 by 3. 2 by 3 is 0.67. Like something here. Here. And if you join these two, we give you a line. This is point minus 2 by 3 and this is 1 2 3 4 5 minus 2 by 3. This is origin. So this is giving you this. Now what is p of x form of x square plus 1, not x square plus 1 minus, and you equate it and p of x equal to this, and you equate this to y. What it will symbolize is this. X square minus 4. If y equal to 0, x equal to 0, y is minus 0 minus y equal to minus 4, and if y equal to 0, x is plus minus 2. 2 and if you see this graph, this is like this. Pass through this x-axis, y-axis, 1 2 minus 2 as 1 minus 2 minus 3 and 1 minus 4. Looks like this. So if I equate x square minus 1 equals 0, 4 equal to 0, then x value plus minus, this plus minus, I will get this one. Equating polynomial to this, you will get this one. Now, one more thing. What if p1, suppose p1x is a factor of p2x. p1 is a factor of p2x, where p2x degree of p2x greater than p1x. Then p2 and p2x is greater than p1x. Degree is also greater. p2x can be written as p1x into, suppose, f of x plus gx. This is normal equation where this is dividend equal to divisor multiplied by quotient plus remainder. Ideally I should write this not f of x, cube of x, and since this is r of x. So if this is a factor, if p1 is a factor of this, see, if 2 is a factor of 8, then you can write 8 equals to 2 into 4 plus 0. Or if you say that 3 is a factor of 12, 12 can be written as 3 into 4 plus 0. Factor means it completely divide this by this, and remainder is 0, which implies that if this is a factor, then r of x will be 0. For this to be a factor of p2, p1 to be a factor of p2x, remainder should always be 0. Now, suppose I will show some example. See, for I'm supposing is it x power 4 plus 2x square plus 4, and I'm saying that x square plus 2 is a factor of this. So if this is a factor of this, then this should completely divide this. So you can even check that if a question says that is this a factor of this. Here the question is asking that if x square plus 2 is a factor of this polynomial, or you can say is p1x a factor of p2x. You can check. Okay, I will check. X power 4 plus 2x square plus 4. Now x power 2, you need, first of all, one thing you should know, that this question can also be given that like this: 2 plus 4 plus 2x square plus x square 4, or 2x square plus 4 plus x square 4. This all are same. And for dividing, you must always write it in descending order. The power should be written in descending order. Not even if this is x power n, then next should be x power n minus 1 factor. Then x power n minus 2. If this is not given, you can switch to n minus 2, then n minus 3, then so on to x power 0. I'm going to have it written in decreasing order. Now, next step is C. How to get x to the power 4 from x square, and similarly with this also, you need to write it in similar form: higher factor, higher degree, then lower degree. Now x square to x power 4. You know that x square into x square is x power 4. So you need to multiply this with x power square. X power square. You get x square 4 plus 2 into x power square. Sorry. 4x. Take 2 as 4x square. 4x square. Then if you subtract this will get cancelled. This will 4 minus 2. This is 2x square plus 4. Now here is x square, here is also square, but there is a factor of 2. So to get 2x square from x square, you need to multiply it with 2. So this will be 2 into x square is 2x square. 2 plus 2 is 4. 2 into 2 is 4. Now if you want to subtract, this will get cancelled, this will get cancelled, remainder is 0. Now since remainder is 0, so you can say that the polynomial p1x, that is p1x is x square plus 2, is a factor of p2x. And what is p2x? P2x is x power 4 plus 4x square plus 4. 4x plus 4. Now one more thing. There is a factor, one thing this is called, this is a factor, and this is zeros. Factor in this zeros. You remember that I have written that x square plus 4, or you can say that x square minus 4 is 0. Px x equal, or y equals, this is if I equal to 0, what I will get the value x square equals 4, x is under root plus minus under root 4, which is nothing but plus minus of 2. What is it? This is called 0, because I have equated this equation to 0. So this is called zeros of this polynomial, which implies that plus 2 and minus 2 are zeros of the polynomial p1x, p1x. I have taken p1x, so I will write it here p1x. Now if a and b, supposing question is given, if a and b are zeros of polynomial px, then you should immediately, your mind should strike that if this is 0, then x minus a and x minus b are factors of polynomial px. And if you multiply these two, this is x square minus ab minus x square minus ax minus bx plus ab is also a factor of this, because I am just have multiplied these two. This is also a factor of the polynomial this. Now if it is given that plus 1 and minus 2 are factors, check if plus 1 and minus 2 are factors of the polynomial x power x square plus x minus 2. You need to check that if this is a factor. See, if this is a factor, then no, this is a 0. If these are 0, then the factor will be x minus 1, x minus or minus 2. X minus 1, x plus 2. Now, so if these two are factor, then if you multiply these two, nothing but this is x cube, this is x square, this 2x. Then if you multiply this is x square plus 2x minus x minus 2. X square plus x minus 2. Now if this is 2 factor of this, the remainder should be 0. So x square plus x minus 2, x cube plus x square minus 2x. Now for x power square, you need to convert to 1 into 3. Then you will multiply it with x. So it will be x cube. Now x into x is x square. X into x is 2x. If you subtract this minus this is plus, this minus this 0, this minus this 0, minus of this plus this is 0. This is 0. Reverse is 0. So since remainder is 0, which implies that x plus 1 or x minus 2 is 0. So individually you can also check. Individually also you can divide x minus 2 with this, then x plus 2, this x plus 2 with this, and for every answer you will get the value as 0. But since you have to do twice, you have to do division twice, it is easier to multiply this 2 and get the answer. Now if it is given individually, I have given that check this is these two are factors. If I have given this in one single part, then you should do multiply this, and if it are given in one part, see, for one part check whether if I will first check first if my plus 1 is factor of this. Now second, check if minus 2 is a factor of this. Then you should first x minus 1, you should divide the polynomial with x minus 1. In second question you should divide the polynomial with x plus 2. Put the value, if you put the value, you will get the desired answer. Now what is given here? They are doing the same thing. Yes. Quadratic equation. Now, a polynomial p of x equals pausing this. Now let us assume that px is a polynomial of degree is 2, and let's just suppose I write it as ax square plus bx plus c. So this plus c. And let us assume that alpha and betas are zeros of this polynomial. Then x minus alpha and x minus beta are roots. And you can see that this is 2, so maximum number of zeros will be 2. Alpha and beta. Maximum can be 2. This thing. So from here, if you multiply x minus alpha into x minus beta, you will get x square minus alpha x minus beta x plus alpha beta equals x square minus alpha plus beta x plus alpha beta equals if if you compare now from here, this is also px because degree is 2 and I'm multiplying this whole 2, this should be equal. No, almost equal. Then if I write this px upper one as a common, x square plus b by ax plus c by a. Now if I compare these two equations, this coefficient of x square is 1, here is 1, here is also 1, and here is minus alpha plus beta equal to this. So from the here and here you can write alpha plus beta equals minus b by a. Now for alpha beta equals c by a, this is a constant, and alpha beta is c by alpha beta is c by a. So this is a thumb rule. It is sum of zeros will be equal to minus b by a, and product of zeros so will be equal to c by a. So next is, now since this the degree is 2, I can call it as quadratic polynomial. Quadratic. Also, if this degree is 2 and I equate it to 0, suppose I equate it to 0, then in the graph you can see that, and this is x, variable of x, you see that it will intersect x at 2 points, maximum 2 points. Minimum can be 0, maximum 2 points. And if degree is 3, it will intersect x-axis at 3 points, a 1 2 3, something like that. Next, now suppose that the polynomial is of third degree, ax cube. Remember, a always be the first with the larger degree, a, then bx square plus cx plus d, and let alpha beta, there I have taken alpha beta, then since this degree is 3, so the total number of zeros will be alpha beta and gamma 3 are zeros of polynomial p of x. So the variable is x minus alpha, the factor will be x minus alpha into x minus beta into x minus gamma. First multiply by this, then you can see that x square alpha plus beta x plus alpha beta into x minus gamma. Now if you multiply this, then you get x cube minus alpha plus beta x square plus alpha beta x, then this minus gamma, then minus gamma x square plus alpha plus beta gamma x plus alpha beta gamma. Now x cube is x cube minus this alpha. Now take all x square, see the x square terms, these two are x square terms, alpha plus beta plus gamma x square. Now see the x terms, this is x and this is x. So if you expand this, this will be alpha beta plus beta gamma plus alpha gamma x plus alpha beta gamma. Now if you can write this expression as a, you can take common, since because this here is coefficient is 1, so here is x a, so you need to take common out a. This is x cube plus b by a x square plus c by a x plus d by a. Now compare these two, 1 1, coefficient is 1, then you can see from this two that alpha plus beta plus gamma. The sum of zeros, here's minus sign, equal to b by a. And here's minus, so minus b by a. Second, product of x terms. X term is c by a. So alpha beta plus beta gamma plus alpha gamma is equal to c by a. And the constant is d by a. And it will not be plus gamma, it will be minus. Here will be minus sign. And it will be minus sign. Minus alpha. So it will be alpha beta gamma equals this minus sign equals to d by a. So minus d by a. So minus plus minus. So sum of zeros minus b by a, product of zeros minus d by a, and sum of any two zeros, solution is c by a. Question can be put. Now next, product of terms is given, this is given, position like this, this, qualification, polynomial, then division, I have already shown. Doing one that I have done. This is done. So next I will be doing, okay, in this only I can do exercise. So coming to the examples in CRT. Note this. I have told you about zeros, what zeros represent. Example 1, see. Look at the graph in 2.9. This is all the graphs, 2.9. Each graph is y equal to p of x, where p of x is a polynomial. For each of the graph, find the number of zeros of px. Number of zeros of px. Here, find the number of zero polynomial px. See, this intersects x-axis and 1, only in one point. So number of zeros is 1. This intersects the x-axis in 2 points, and number of zeros of px is 2. This intersects the x-axis in 3 points, 1, 2, and 3. This is 3. And this intersects x-axis only at 1 point. So this number of zeros of polynomial px is 1. This also intersects the x-axis at 1. The number of zeros is 1. Notice there will be 2 zeros on, but the value will always be 1. Here it will insert 1, 2, 3, and 4. 1, 2, 3, and 4. So this number of zeros of x is 4. 3, number of 3, 1, 1, 4, 1, 1, 5. 5 is also 1. Y by the algorithm is giving y. Oh no, sorry. 2.1. Exercise 2.1. Exercise 2.1. Question number 1. This. So, in exercise C, see, first is this. Now, this never intersects x-axis at no point. So, zeros, number of zeros is 0. Now, for second, this intersects x-axis at 1 point. See, this intersect x-axis at only 1 point. So number of zeros of this polynomial will be 1. Next, this intersects x-axis at 3 point. So this question, the figure is given here. The x-axis is here, here, and here. X, y, x dash. This is y dash. Y dash. 3 points. So number of zeros for this will be 3. Now, fourth question. First question, fourth part. This intersect x-axis at 2 points. Now, for let me draw some different diagram. Now, this intersect this at 1, 2, 2 points. So number of zeros will be 2. Next, 1, 2, 3, 4. So next is 1, 2, 3, 4. This intersect x-axis at 1, 2, 3, and 4. Number of zeros will be 4. The number of times cut the x-axis is 4. Now here it touches the x-axis, though it is 1. So this is after I draw the diagram. Understand it. Diagram in a better way. So this is like not like the distance. Just touching here. So number of that crosses or intersect the x-axis in 3 points. So number of zeros will be 3. This exercise over. Now relationship between zeros and coefficient of the polynomial. This is relationship between zeros and so. This is not a question. Product of zeros, sum of zeros. They are doing the same thing, and they have also done the same thing. K is a factor, and alpha plus beta, sum of zeros is minus g by n, and alpha beta is c by. Now, example number 2. Find the zeros of the quadratic polynomial this and verify relationship between zeros and coefficient. Zeros and coefficient. C 0. So x square plus 7x plus 10. X square plus 7x plus 10. X square plus 7x plus 10. Now you need to find the zero, so I equate this p of x equals 0 to find the 0. So take, so if you put x equal to 1 in this, you need to not show this. I'm writing this if you don't want to this is not to be shown in the exam. Just for information, if you put x equal to 1, this is 1 square plus 7 into 1 plus 10, which will be give you not something which is not 0. Now if you put x equal to minus 1, then this will be positive, this will be negative, this will be positive, but still not 0. Now you know that if you put negative numbers here, then this will always be positive, this will always be positive, and only this will cancel the sum of these two. So next number you should take is equal to minus 2. Now if you take x equal to minus 2, what will this become? This plus 10. This is plus 4. This is plus this is minus 14 plus 10. Now 10 plus 4 is 14, and minus 14 is 0. This will give 0. So if x equal to minus 2 makes this polynomial 0, then you know that x plus 2 is a factor of p of x. Now see, x plus 2 is a factor. Now I am showing how to x square plus 7x plus 10. Now x square plus 7x plus 10. How to write this? See, and you know in your you have calculated that x plus 2 is a factor. Now see, there is a x square and there is x plus 2. Now there is nothing here, nor x square, nothing here. So you can write that x square plus this is 2, so 2 of x. You multiply it by x, so you get x square plus 2 of x. Now see, if this is 2 has gone here, this is 7x, so net will be this 7x is distributed. This will be written as, this is distributed as 5x plus 10. Now you can take x common, x plus 2. Now here you can take 5 common. You take 5 common, this is x plus 2. Now x plus 2 you can take common from this, which is x plus 2, this is x plus 5. X plus 2 into x plus 5. You can written that x plus 2 plus x plus 5, which implies that if you equate this to 0, then either this or this, both these both will equal to 0, which implies that from here x plus 2 equals 0, which implies x equals minus 2, and from here x plus 5 equals 0, implies that x equals minus 5. These both are zeros of the equation. P of x equal to 0. Now alpha, let us take alpha to be minus 2 and beta to be minus 5. In sum of the zeros, alpha plus beta is minus 7, which is, you can say that this minus 7 is same as minus of minus 7, minus of plus 7. So this, now if you put product of this alpha into beta is nothing equal to minus 2 into minus 5, nothing but 10, which is nothing but here, this by this, 10 by 1, here is 1, so 10 by 1, and 7, so 7 by 1 is equal to 7 by 1. Hence you can prove, hence it is proved that this is like this. Third, find the coefficient of polynomial x square minus 3. Find zeros of this and verify the relations with zeros and coefficient. X square plus 3. So x square plus 3. This part of this. So this is x square minus 3. This is x square minus 3. So x square minus 3 equal 0. 0 means x equals under root 3 plus minus. So you can say that the value, you can directly calculate from here that alpha, let us assume alpha, one of the root is minus root 3, one of the root, that is beta, is plus root 3. Now what is alpha plus beta? The sum of zeros, minus root 3 plus of plus root 3 by 0. From here if you expand this, you can that ax square plus bx plus c equals 0. Here b value is 0. From here you can say that value of a, if you compare this to, value of a is 1, value of b is 0, and value of c is minus 3. So from here you can say that this is 0 by 1, which is coefficient of x by coefficient of minus of this alpha beta. What is alpha into beta is equal to minus root 3 into plus root 3, nothing but minus of 3. This minus of 3 is nothing but equal to coefficient constant term, minus 3 is constant term, so constant term upon coefficient of x. So from here it is proved that this is this. Now example 4, find the quadratic polynomial and the sum and product of whose zeros are this and this. Sum and product of zeros are this and this. So from here it is given that sum is sum that is alpha plus beta, nothing but minus 3, and product is alpha beta is plus 2. Now if we assume that the equation is x square plus bx plus c, ax square plus bx plus c, polynomial is this, and if you take it to be common, x square plus bx b by a plus c by a, and from here alpha plus beta is minus 3 equals minus of b by a, which implies that b by a equals 3, and alpha beta is 2. Alpha beta is 2 equals constant term c upon coefficient of a, which implies that this is equal to 2. Now taking a to be 1, better to take a to be 1. So from here if you take a to 1, then b is 3 and c is 2. So the expression becomes x square plus bx, b by ax, b by a is 3x plus 3x plus 2. This. If a equal to 1, then b is this, c is this. See that? 3x plus 2. Solving this, you get this. Now this is third degree equation, this is here. So verify that these are zeros of the cubic polynomial, this, and then verify the relationship between zeros and the coefficients. Now verify this and this are zeros of this polynomial. So I need to teach one more thing, that if for polynomial p of x is 0 for x equal to alpha, then p of alpha is 0. Alpha is 0. Meaning that if p of x is given to be as, suppose 3x square plus 2x plus 2x minus 5, and suppose, and x, and it is given that minus plus 1 is a 0 of p of x, then you can say that if I write p of 1, that is value of, substitute the value of x as 1, then it will get me 0. Definitely give the expression to be 0. Here you can also see that 3 into 1 plus 2 minus 5 nothing but 5 minus 5 equals 0. This is one of the property. Now, based on this, this question has been given. Verify that 3 minus 1 and minus 3 are the zeros of the cubic polynomial. This is in this. Now, if you substitute the value of 3 here and solve, this will be 0. Minus 1, solve, this will give you 0. And minus 1 by 3, solve, this will give you 0. They have also solved this. This will get 0, 0, 0. Now, comparing both the standard formula polynomial is ax cubed plus bx squared plus cx plus d. And from here, if you add alpha plus beta plus gamma, it will give you minus b by a. If you add alpha beta gamma, you get the alpha beta gamma is this. And if you add alpha beta gamma in nothing but 5 by 3, which is minus of minus 5 by 3, which is minus b by a. And similarly, alpha beta beta gamma alpha, this is 3 of this, and if you solve this, will give you c by a. And alpha beta, if you solve this, multiply this will give you minus d by a. You can verify from this, and you will prove that yes, these are zeros, and it has been verified. Thank you, and exercise will be shown next